Good afternoon, math students. I'm Mr. Hajgassam, and today we're going to learn about the circumference of a circle. Now, you will learn about the relationship between the diameter and the circumference. From that, you will be able to calculate the circumference of the circle, and then from there, we'll be able to calculate the arc length of a sector or circle. So before we start, I just want to go through something in relation to fractions. So here we have, it says calculate 2/3 of 60 pounds. Now, one thing you can do is divide 60 into 3 parts to find what 1/3 is worth. So 60 divided by 3 will be 20. And then you multiply that by 2, which will give us 40. And this is a more conventional method of doing this. However, the word of here, so I'm just going to use my pen. The word of means multiply. So whenever you want to work out a fraction of an amount, the word of means multiply. And we can rewrite this as, so if we were to use mathematics, 2/3. Instead of, we can do the multiplication sign and then of 60 pounds. And rather than writing 60, I will write 60 over 1. So I just have to multiply the top or the numerators to get the numerators together, and then I will have to multiply the denominators together. So 60 times 2 will be 120, and 3 times 1 is just 3, and this will give us 40 or 40 pounds in this case. So we need to remember this fact when we're dealing with arc length. Now, moving on from here, so I'm just going to clear the screen. So let's talk about the different parts of a circle. So the distance around a circle is called the circumference. So this orange line here that we will shortly see is the circumference of the circle. The distance from the center to the circumference is the radius, and that would be a radius. Now I can have a radius again from, let's say, here all the way out to here. That should be a straight line, so I do apologize, it's a little bit wonky, but the distance from the center to the circumference will always be the radius. This red line here, if it was a straight line, will also be a radius. And then the distance from one part of the circumference to another part of the circumference, cutting through the center, will be the diameter. So this is what a diameter would look like. Now, there is also a relationship between the radius and the diameter. If we look closely, from here, from the center to the circumference, we have one radius. So from here to the circumference, we have one radius. And again, from the center to the circumference, we have another radius. So what we should be able to realize is that 2 radiuses or 2 radii are equal to 1 diameter. And this is another important relationship we need to understand. Okay, moving on from this. So again, I'm just going to clear my screen. We need to also understand what we mean by the arc length. So the arc length is any part of the circumference. So this yellow line here, that is an example of an arc. And then we create a sector by creating a slice. So an arc bounded by 2 radii creates a sector. So this area that's enclosed by the radii is the sector. All right, now here's a question for you. Let's imagine we have car A, or the yellow car actually, starting at point A, and the blue car starting at point B. Now the blue car wants to go across the diameter of the circle, so going from point B to point A, and the yellow car wants to go around the circumference of the circle, so starting at point A and then going all the way around back to point A. So my question is, if you want to pause the video, how long or who will complete their journey first? Now, it's quite clear the yellow car will take longer to complete its journey, and the blue car will take, it will be quicker for the blue car. Now, another question is approximately how much longer will it take the yellow car to complete its journey? And the answer to that, so again, you can pause the video if you want to think about it, but the answer to that would be it would take the yellow car just over 3 times longer to go around the circumference than it would the blue car. So what that tells us is that the relationship between the circumference and the diameter is that the circumference is approximately just over 3 times longer than the diameter. And this is really important to understand when we want to be able to work out the circumference of a circle. And if we were to create or derive a formula for the circumference, well, using our estimation, we could say that it takes 3 times longer to go around the circumference. Therefore, the circumference is equal to, and this is an approximation, it's not exact, would be equal to 3 times the diameter of the circle. And this is true for every circle. Now notice here, I've used the number 3, but actually we said the relationship is approximately just over 3, and the number that's just over 3 is called pi. So I'll just give you a clearer definition on the next slide. So I'm just going to clear this up and moving on. So for any circle, the circumference is always just over 3 times bigger than the diameter, and the exact number is called pi. Now pi is a recurring decimal and non-terminating. So this number will keep going to infinity. And this is pi to 200 decimal places. And pi is represented by this symbol. All right, so to calculate the circumference, rather than doing 3 times the diameter, we would do 3 times the diameter, or another way of writing the formula for the circumference will be 2 pi r. And this goes back to the relationship between the radius and the diameter. So we said if we have 2 lots of radii, that would make 1 diameter. So we can rewrite this as pi times 2 lots of radii, and that becomes 2 pi r. Notice this is more of a conventional way of writing the formula. So let's do some calculations then. Let's calculate the circumference of a few circles. Now actually, before I move on, just a quick reminder to find pi on your calculator, because generally you would get area questions in relation to a circle on calculator papers. You would have to press the shift button on the top left-hand corner of your calculators, and then the pi button is down here, as we can see in yellow. All right, and moving on. So first question, calculate the circumference of the following circles. Now, again, if you want to pause the video, you can and have a go at these by yourselves. But I will go through them during this period. So the diameter is 11. Notice the distance from one side of the circumference to another side cutting through the center, even though on this occasion we can't see the center point. Usually you will be able to, so I'll just draw that in. So let's say that is the center point of our circle. So circumference is pi times the diameter, so we can work that out as pi times 11. And if we type that into our calculators, we'll get 34.6 meters to 1 decimal place. With this purple example, we have the radius. So we could either use 2 pi r, as we have here. So that would be 2 times pi times 9, which will give us 56.5 meters. And in the last example, so here I'm just going to use pi times the diameter, and that would be pi times 10, which will give us 31.4 centimeters. All right, now we have a semicircle here. So here it says find the circumference of the semicircle. So again, the process will be the same, but this time we just have half of a circle. So if I was to draw the full circle, it will look something like this. Again, this is not drawn to scale, so apologies for the uneven lines. But if we were to work out the full circumference of the semicircle, so that would be the distance that I've just highlighted in red. Actually, maybe I should use another color. So I will use green. So this would be the distance that we want to calculate right now. So again, we would have to do pi times the diameter. So the diameter is 10, and that will give us 10 pi. So you can even write your answer in terms of pi. But that would be for the full circumference. So what we'd have to do for half of the circumference is do 10 pi divided by 2. And that would give us 5 pi. And 5 pi, if you type that in your calculators, as I will do, 5 shift pi, that would give us 15.7 to 1 decimal place. So that would be 15.7 centimeters. So that would answer the first question, the circumference of the semicircle. Now it says find the perimeter of the shape. So the perimeter is the distance around the shape. So what we would have to do is add the arc length to 10 centimeters. So that's going to be 15.7 plus 10, which is going to give us 25.7 centimeters. All right, moving on to the next example there. So here, if you notice, we have a sector, and this sector is a quarter of a full circle, and we can see from the angle that's created there, this is a 90-degree angle, so this is a quarter of a circle, and if I was to draw the full circle, it would look something like this. Again, I do apologize, this is not drawn to scale, but I can create 4 other sectors and all of the angles will be 90 degrees. And 4 lots of 90 degrees will give us 360 degrees. So angles around a point add up to 360. And that is true for all circles as well. So what we can see then is that the radius of our sector is 3 centimeters. So this is also a radius, this distance here, so that will also be 3 centimeters. And we want to calculate the perimeter of the shape. But before we do that, we need to work out this distance here that I've just gone over in green. And this distance is part of the circumference. So again, what we can do is calculate the full circumference. So that would be pi times the diameter, which in this case is going to be 6. So that would be 6 pi. And then if we want a quarter of the circumference, because this distance here is a quarter of the full circumference, we would have to do 6 pi divided by 4, which is going to give us 3/2 pi. And if we type that into our calculators, that will give us, 3 divided by 2 times pi. It's going to give us 4.71 centimeters. All right, now notice what I said. We said we want a quarter of the circumference. So another way I could have written this, so going back to what we did right at the start of the lesson, I could have done 6 pi multiplied, so a quarter of the circumference. So the word of means multiply, and we want a quarter of the circumference. So it will be 6 pi times 1/4, which will give us 6 pi over 4. which will simplify to 3 over 2 pi. All right, moving on. So let's make this a little bit more difficult. So I'm just going to clear all the drawings. Now here we have a sector, and we will have to work out the arc length. So that would be the distance from A to B. So again, it will be this distance here. And again, I'm just going to draw the full circle. Actually, I think I have that on the animation. There we go. So this would be the full circle, and we just want a fraction of our circle, or actually a fraction of the circumference. Now, to work out that fraction, we will use this angle here. So we will use this angle out of 360 degrees, because as I said previously, angles around a point add up to 360 degrees. So the full circle will give us 360, but we want this angle here. So the arc length would be theta divided by 360 times the circumference. So theta over 360 gives us the fraction of the circumference we want. So this would be the fraction of the multiplication sign, the circumference. So if I go back to this example, what we would have is, would be 60 over 360. So that would be 1/6. 6 over 36 will simplify to 1/6 times the circumference, and the circumference will be pi times the diameter, which is going to be 24. And we can simplify this to 1/6 times 24 pi which will give us 24 pi over 6, and 24 over 6 is 4, so our answer will be 4 pi for this arc length here. Right, let's do another example then. And if you type in 4 pi, you can get your answer to however many decimal places the question asks of you. All right, so moving on here, I'm just going to clear the screen. Right, so we have calculate the arc length of the sectors. So again, to do that, firstly, I can work out the circumference. So circumference is pi times the diameter. So that's going to be 6 times pi, which is simply 6 pi. Notice that this is the center point of our circle. Therefore, the distance from the center to the circumference, this arc is part of the circumference, will give us the radius. So if the radius is 3, the diameter is going to be 6. So we want a fraction of this circumference. And to find the fraction we want, we would do 66 over 360. So that is the fraction of the circumference that we want. So rather than saying of, we will say multiply by 6 pi, 6 pi being the circumference. So this is the fraction of the circumference. Notice this arc length is a fraction of the full circumference of our circle. If we were to draw it going all the way around. And 66 over 360, so we can type that into our calculator. Multiplied by 6 pi, and that will give us 3.46 to 2 decimal places. 3.46 centimeters to 2 decimal places. So that would be this arc here. Now, in the next example, excuse me, in the next example, so again, our radius is 3, so therefore our diameter is going to be 6. To find out the fraction of the full circumference that we want, we would use this angle here. So that's going to be 158 over 360 multiplied by, again, the full circumference would be pi times the diameter. So that's going to be 6 times pi, which is simply 6 pi. And if we type that into our calculator again, so we would do 158 over 360 multiplied by 6 pi, that will give us 8.27 to 2 decimal places. All right, and so moving on. So we have a couple of, and actually this is the last question, which is a challenge question. So if you want, you can pause the video and have a go at this, and I will quickly go through it before we end. So I'm just going to clear all drawings. So here it says, find the perimeter of the shaded shape. So that would be this shape here. So we want this distance, we want this distance, we want this distance, and we want this distance. Now what we know is that the distance from here to here, so from this point to this point, is 2. So this is also going to be 2 meters. And to work out this distance here that I've just highlighted over, we would have to use the information we have over here. So this arc length is going to be 80 over 360. So that gives us the fraction of the circumference that we want, multiplied by, notice the radius of this sector would be 3. Again, if we were to expand and draw a circle, this would be the center point. So that's going to be pi times 6, which is going to be 6 pi. And if we type that into our calculator, that would give us 80 divided by 360 times 6 pi will give us 4.1 meters. So this distance here, or this arc length, is 4.1 meters. Now, we have to find the arc length at the top as well. So I've just drawn over it in red. Now, similarly, the angle of this sector is still going to be 80 degrees. I'm just going to show the sector that we're talking about. But the radius is going to be different. So the radius this time around is going to be 3 centimeters plus 2 centimeters. So our radius is actually 5, making the diameter 10. So for the red arc length, we would have to do 80 over 360 multiplied by or the fraction of the circumference that we want. So the circumference is going to be pi times the diameter. So that's going to give us a diameter of 10. And that's going to be 10 times pi, which is 10 pi. And that will be equal to, oops, apologies, just rub that out. And that will be equal to 80 divided by 360 times 10 pi, 6.98. So we will round that up to 7 meters. So this arc length is going to be 7 meters. So the question asks, work out the perimeter of the shaded shape. So it's going to be 7 plus 4.1 plus 2 plus 2. Do not include the 3 here. We just want the perimeter of the shaded shape. So that's going to give us 8.1, and plus 7, it's going to be 15.1. So the perimeter, I'll write with a different color pen. So the perimeter is going to be 2 plus 2 plus 4.1 plus 7, which is going to be equal to 15.1 meters. Right, I hope you enjoyed that, and I hope you found that useful. Just to do a quick recap, to find the circumference, we would multiply the diameter with pi. Remember, the relationship between the circumference and the diameter is 3:1. So the circumference is 3 times or just over 3 times the diameter. And if you understand this relationship, you will never have any problems which involves calculating the circumference. And when you come to calculate the arc length, you want to calculate a fraction of the circumference. And to find that fraction, you will use the angle that is created at the center of the circle. Thank you for listening, and I hope I will see you soon. Have a nice day. Bye.